In this video, we're going to learn how to visualize embeddings using t-SNE. Now, embeddings give us a way of representing a piece of content in semantic space with a bunch of numbers, and similar content should be near to each other. We're going to use embeddings of YouTube comments using a dataset that I've put on Hugging Face, but you could do the same thing with product reviews, posts on Twitter, email replies, and so on. Let's go into the IPython shell. We're going to load some dependencies. So those are the Hugging Face datasets and the rich console. And then we're going to load the dataset and have a look at it. So you can see we've got a video ID, we've got a title, we've got a channel, and then the most important bit for this video is under comments, where let's have a quick look what's inside there. So we'll get one of them and we'll have a look at the keys. So you can see we've got an embedding and then we've got the text. So let's quickly have a look at the text. So you can see these are a bunch of comments from one video about Claude 3 and GPT-4. And then if we have a look at the embeddings as well, you can see they are a bunch of numbers. Now each of these embeddings contains 768 elements, which makes them quite difficult to visualize as is. So we need a way to reduce those 768 dimensions to 3 or maybe even 2 dimensions so that we can visually see the similarities between embeddings. Now t-SNE or t-distributed stochastic neighbor embedding is a statistical method that does this. And the way it works is it converts the relationships between data points into probabilities that reflect their similarities, and it then tries to maintain those similarity relationships while iteratively adjusting the positions of those embeddings in lower dimensional space. So let's have a look at the code that does this. So this is an app.py, so this is a Streamlit application. You can see we start by importing a bunch of modules, including t-SNE from scikit-learn and then plotly to do some visualization. And then we configure our page, so setting up the margins and so on. Then we're creating a little sidebar where we load that data set that we talked about before. We're then rendering the selected video. And then we've got a bunch of parameters that we're going to use for the t-SNE algorithm, and we'll see those in a little bit. So then if we come over to the main part of the screen, we're getting out the embeddings. We're also rendering to the screen how many comments we're working with. And then let's finally have a look at the last bit of code, which happens when the submit button is pressed. So you can see we start off, we call the t-SNE function and we fit it on the embeddings and we get back a data frame. We also put in the comments so that we can then see those on our visualization, which we do with a scatter plot in Plotly, and you can see we're using the hover text to render the comments. And then we just tidy up the visualization and render it to the screen and then print out how long it took to render. So let's go over to our browser and have a look what it looks like. So you can see on the left-hand side, we've got a picture of the video that's been selected, the parameters, and then on the right-hand side, it's going to be the visualization. So let's press that visualize comments button. And we'll see we've got a visualization. So this is the first one for the video, new Claude 3 beats GPT-4 on some metrics. And so if we look through it, you can see there are clusters around calling the cup and the ball. There's then another one talking about OpenAI and Sora. We can then go and tweak those parameters. So one thing that we can tweak is the metrics. So the default is Euclidean distance, but often for text embeddings, people will use cosine similarity instead. So let's see what happens if we change it to that. So I think this is reasonably similar. It's not obvious to me that this has made the visualization any better, but let's have a look around. So we can see there's one there saying that's a nice video. If we look over on another one, we can see they're talking about Mistral large. Those a few comments have been clustered together there. We can also tweak the number of iterations that process, which is taking the huge dimensionality down to 2 dimensions, is taking. So let's put it to 250. That's the minimum that you're allowed. And you can see the visualization is useless, right? It hasn't really worked at all. Like I said, this is not helpful. So let's put that back to 1000. And we'll also tweak the perplexity. Now, perplexity is used to work out how many neighbors do I want to try and stay close to when it's reducing the dimensions. So it's defaulted to 30, but because we've only got about 200 comments, that's probably quite a lot. So we're getting, like, it's trying to put everything kind of close together, and maybe like we'd want to try and find some smaller clusters. So let's set that to 5 and we'll see what it looks like. And so you can see now it looks you can see quite a big difference from the previous one. We've now got some small little clusters of things. So let's have a look at some of them. So there's one which is talking about the snake game. There's another one, it's OpenAI and GPT. There's another one again, Mistral large. And then again, we've got the marble and the ball. We can also tweak the method that's being used on these iterations. So it defaults to an approximation method called Barnes-Hut, but we can change that to exact, which takes longer and usually you wouldn't be recommended, but since we've only got a small number of comments, it probably will be okay. And so if we run that, we can see again, you can kind of see the little clusters that it's pulled up. So you can see there's one over there about AGI, there's another one about OpenAI needing to move forwards. Let's have a look at what happens if we use this for another video. So let's select another one. So this is the Elon Musk files bombshell lawsuit against OpenAI. So this one has almost 400 comments, and you can see it takes a few seconds to render. And then if we look at the clusters that we've got, there's something about a Hollywood movie, there's one going, hey, let's go Elon, there's another one about AGI, and then again, we've got two clusters about AGI. So if you liked this video, check out this other one up here where we learn how to use embeddings to make content recommendations.